Hello, everyone. Today, we're going to be solving square root equations. So we're kind of transitioning away from just the simplifying into the actual solving part of things. So as always, before we get started, if you could take a minute and try the Ignite at the top of the page, pause your video now. All right, final answer is up. You should have got 3 plus 2 root 6, all divided by 10. Now, just like no matter if it's a complex number, if there's i's involved, or just radicals, remember you're not allowed to have either of those on the denominator of fractions. So we have to go through and rationalize the denominator. So we multiply both the top and the bottom by the same quantity of what's on the bottom, just with the flip sign. So when you do that, you should have been left with the 4 root 6 plus 6 on the top, and on the bottom, the two middle terms should actually end up canceling. The plus 4 root 6 minus 4 root 6 cancels, and you're just left with root 10 on the denominator. Now, a lot of students tend to want to stop here. Ooh, no, I'm sorry. A lot of students want to, or have a tendency of wanting to stop here, but remember, we have to check to see if anything on the outside reduces. And 6, 4, and 10 all reduce by a factor of 2. So if you divide them all by 2, you should have got, ooh, and I just realized, I'm sorry, guys. That should be a 5. My bad. Nope, 10 divided by 2 is 5, and there we go. All right. Now today we're gonna not do quite as much rationalizing the denominator as much as we are gonna get into the solving pieces. So when it comes to solving this equation right here, really, again, we're asking ourselves the question, well, what number squared gives us 16? And this is where we have to be careful, because a lot of us only say there's one answer. We say, oh, x is 4. But there is more than one answer to a question like this, because there's 2 numbers out there that when you square it, gives you an answer of 16. And it's not just positive 4, it's also negative 4. Now, if you'll remember from Algebra 1, there is a process that we used to go about undoing squared. Now, obviously, solving by factoring is when there's like an x squared plus 3x minus 7 equals 0. We use factoring when there's a squared term and a term that's being raised to the first technically. But the nice part is that if there's only a squared, there's actually a nice operation that undoes something that's being squared. And it's called the square root. So if I want to undo squaring, I want to cancel out the square, just like we use multiplication to undo division. Addition undoes subtraction. To undo squaring something, we use square roots. Square roots undoes squaring, and squaring undoes square roots. It's vice versa. But just like all equations in algebra, what you do to one side, you also have to do to the other. So it's a pretty easy way, especially if you don't know what number squared gives you 16, all you have to do is square root both sides. Now, when you actually simplify though, when it's an equation, when you draw your own square root in, you have to remember to use the fact that there's 2 answers. Whenever there's a square root, whenever you draw it in, it's nice to get in the habit of always putting a little plus minus with it. And then we simplify. Square root of 16 is 4. So this is actually, in terms of ways to write your answers, that is one of the ways. You can write your answer as x equals plus or minus 4. That's fabulous. If you are that student, you like writing them separately, you can write it separately like this as well. It does not matter which way you write it. You do have to recognize, though, that there are 2 solutions, okay? So why do we need square roots? They are the inverse of squaring. So especially if we can avoid factoring, it's easier to use square roots at the end of the day. Like this one, you're probably looking at this and you're saying, all right, get one side equal to 0, factor and go. Could you do that? Possibly. The problem is, though, is that a lot of these, factoring really only works when it factors nicely. And most of the time, if we involve square roots, most of the time it doesn't actually factor really nicely. So that's where solving for square roots kind of comes into play. And to do that, there is one main thing we have to remember. We have to isolate the variable, or isolate, I'll say the squared. So we have to isolate whatever variable or thing that is being squared. And I say thing because sometimes you might be squaring a quantity of something. But at the end of the day, the nice part about this is we kind of set this up similarly to as if there was no squared with this. If there was no squared, think about what your steps would be. Hopefully you would subtract 5 from both sides, and then you would divide by 3. Fun fact, we don't do anything differently. We would start by, again, subtracting 5 to the other side. And if I take 41 minus 5, we get 36. And then we're going to do exactly that. We're going to divide by 3 on both sides. 36 divided by 3 is going to end up being 12. Now, typically, obviously, if that squared wasn't there, we would be done. But we have a squared, which means I need to undo the squared aspect by using my square roots. And when I add that in, I want to make sure I add a little plus minus with this. So your answer is going to be plus or minus whatever the square root of 12 is. But just like all other radicals, we want to make sure that we simplify. You bet you thought this was going away, but it's not. We want to make sure we go through it, simplify for 12. You could do 6 and 2. You really don't want to do 1 and 12. I chose 3 and 4. And remember, you want to break these down as much as possible. So those are the numbers on the ends of my branches. So remember, anything with a buddy comes outside, and anything that doesn't have a buddy gets put back on the inside. So remember, when we solve using square roots, we are never going to write our answers as decimals. It's not considered simplified, and it's not considered exact, more importantly, because if you have to round a decimal, you're cutting off parts of the number. So if you write your answer as a decimal on these, all of them are going to be marked wrong. Okay, not to be negative, but just letting you know, when we say solve, it's implied when using square roots that we keep them as exact as possible. So same thing. How about I want you guys to pause your video, and I want you to try example number 2. All right, hopefully you're looking and you got the same answer. This one you do have to be a little bit careful, simply because you solve exactly the same way as we did before. You should have subtracted 8 first, divided everything by 6, and then square rooted both sides. But we have to be careful, because even though square root of 13 doesn't actually simplify, the fact that we have a negative on the inside of a radical means that we have a complex number. So you have to remember to pull out the I in any case that happens. So you don't have to simplify the square root anymore, because square root of 13 doesn't simplify, but you should have got final answer of plus or minus I root 13. You could have written your answer again as you could write it as x equals I root 13 and y equals negative I root 13. If you want to write those as separate answers, that was also acceptable, okay? Now, even when you start dealing with some problems like this where you have some more complicated pieces going on, again, you still follow the rule. The rule is isolate the squared part of the equation. So to do that, right now we have a 4 on the outside. So that's the first thing that I'm going to get rid of. Because once I add that 4 to the other side, the nice part about, that didn't work, sorry. The nice part about where we're at is that the squared part, this is what I mean when I say the squared part is alone, because there's no numbers in front. There's nothing being added or subtracted on the end. We are simply just x plus 3 being squared. So even though it's a quantity, we still now, because we have everything being squared on one side, we can now undo the squared by square rooting on both sides. Now, just be careful, because when you do that, we have to make sure to add that plus minus and simplify what's under the square root. Now here, that's pretty nice, because square root of 36 is a perfect square, and 6 is the answer to that question. Now, keep in mind the directions. The directions do say solve. So solve means get the variable alone on one side. So especially when you have something like this where there's more to do, I usually like to split up my final answers. I'm saying, all right, well, whatever x plus 3 is, it could be equal to positive 6, or x plus 3 could be equal to negative 6. That's what this plus or minus means in front. And then we can solve. If I subtract 3 to both sides, we get x is going to be equal to 3. Subtract 3 on those sides there, and we get x is equal to -9. There are your two answers. All right. So I want you guys to pause your video, and I want you guys to try example number 4 on your own. All right. You should have gotten -3 plus 2 root 2 as your final answer. So let's walk through this. First step, you should have got the x plus 3 squared part alone. So your first step should have been to divide by 2 on both sides. And that leaves you with the x plus 3 squared, which means your next step should have been to simplify by square rooting both sides. Now be careful, because that's the step where, remember, if you have a square root of 8, you do want to make sure to see if it simplifies. And square root of 8 does, it simplifies into 2 root 2. So really your last step then is just to get x alone, which means just subtract 3 to both sides. So I kind of showed the split way, which is kind of like this part right here. If you split yours up into 2 different equations, your answers would have looked like this. If all you did was subtract the 3 to both sides, just be really careful that these numbers don't add, because this 2 is part of the 2 root 2, and you can't add something to something being multiplied with something else. Kind of like the same concept goes if I were to do 2, whoopsies, plus 2 times 4. You can't add the 2 plus 2 together before you do the 2 times 4. So just be really careful about that when you go about simplifying that. But either way you chose to write your answer, you should have got a final answer of -3 plus or minus 2 root 2. Okay. So I got a couple of challenge problems. I'm going to do one with you just to kind of get you started. I'm going to do number 5. So again, first step, we want to get the squared piece alone, which means I don't like that there's a subtracting 10, and I don't like that there's a -3 in front. So just like any equation, I'm going to start by adding the 10 over to the other side. And then we're going to go all about dividing by what's in front. Divide both sides by -3. Woo. And we're going to be left with w minus 2 squared equals 39 divided by -3 is -13. So my next step, I'm suspicious that I'm probably going to have some complex numbers, because the next step is once the squared part is alone, we square root both sides, and the square root cancels out with the squared. We just can't forget about adding in that plus minus on the inside here. And here's where, if I have that square root of a negative number, our next step has to be to take care of the complex number. The negative comes out as an I. And we would check to see if the square root of 13 simplifies, but it doesn't. Square root of 13 is as simplified as it goes. So really our last step is just to complete the solving process. I'm going to add 2 to both sides, and I'm going to add 2 in front, because I can't add it to the I root 13 because those are being multiplied. So final answer is 2 plus or minus I root 13. All right. So what I want you guys to do, I want you guys to pause your video, and I want you guys to try example number 6. All right, final answer. You should have got -3 plus or minus the square root of 35. Your first step should have been if we have a fraction in front, you could have either divided by 1/5. I chose to go the other route. I multiplied by the reciprocal. So I multiplied by 5/1. But either way, fun fact, you get the same answer, and you get 35 on the inside. And then my next step, because now the x plus 3, the piece that was being squared was alone, I square rooted both sides. So when you do that, just don't forget about putting the plus minus with it. Square root of 35, we would check to see if that actually simplifies, but there's no numbers other than 1 and 35 that breaks down into, which means your last step is to finish solving. I'm gonna, in order to undo the adding 3, we subtract 3 from both sides, which leaves you with your final answer of -3 plus or minus the square root of 35. Again, now you could write your answers separately. You could say x equals -3 plus the square root of 35, and x equals the -3 minus the square root of 35. Either way that you wrote it, both are fabulous, okay? Now, what kind of day would it be without doing some notes problems? So we are going to introduce our first type of projectile problem. And for this one, this formula is something that's going to be pretty common. You're going to see this a lot. We use this in a lot of different quadratic problems. And the variables in there mean something pretty specific. This h sub naught, you might have seen this actually in physics if you've taken it yet, but this just means basically it's the starting height. So for example, if whatever we were doing was starting, if whatever was being launched or thrown or kicked or hit or whatever the case is, if it was on the ground, your starting height would just be 0. But in this case, it says for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. So if it's off the ground that much, that's kind of your hint that that's going to be our starting height. So if we are going to go about solving, this says, I know for a fact that h sub naught for us is going to be 50. Now, t just represents the time that it takes to usually to reach the ground. Now, this negative 16, you're probably wondering where that comes from. That has to do with gravity. For solving purposes, you just have to know that negative 16 is never going to not be in this problem. Okay, if I have a negative 16t squared plus 50, that is going to represent h. Now, this h on the left side is something that's different from the starting height. This might be, you might want to end this or add this to your defined variables, but this is the height after t. And usually there's units. A lot of times, like for example, this one, it says, if it doesn't say, it's implied that it's after seconds. It could be like after minutes, hours, but most of the time when we use this equation, t is always going to be measured in seconds. So for example, it says, how long does the container take to hit the ground? So simply the fact where it says, I want to know how long it's going to take to hit the ground, we don't know the time it takes, but I know for a fact that we're trying to find out, well, when would this be 0? All right. So in order to solve, let's solve for the time it takes. And to do that, all we have to recognize is that because we have a squared variable in here and no single variables, I can solve this using square roots. So my first step is going to be to subtract 50 over to the other side. I want to isolate this variable. So we're going to be left with negative 50 equals negative 16t squared. We're going to divide both sides by negative 16 because, again, I want to get t alone. I'm going to continue up here. So we're going to be left with t squared equals, not exactly the nicest answer, but in word problems, this is not something I'm going to really make you simplify. So on the inside, if you type that into your calculator, you get 25 over 8. You can write the decimal if you want to, but for our purposes, all we're going to do next is continue solving. And we're going to square root both sides. You do not have to keep this exact because it's a word problem. So we do get 2 answers. We're going to get plus or minus whatever the square root of 25 divided by 8 is. And if we round to 2 decimal places, it turns out to be 1.77. Now, because this is time, we have to really think about what makes sense. So really, you're saying 2 things. You're saying the time it takes to reach the ground could be 1.77 seconds, or you're saying the time it takes to reach the ground is negative 1.77 seconds. And hopefully you're realizing that one of those is an issue because we cannot go back in time. So whenever it comes to word problems, basically we kind of just ignore the negative answer because it doesn't make sense from a real world perspective. For all intents and purposes, if I said how long would it take that egg to reach the ground, it takes about 1.77 seconds if it was dropped from a height of 50 feet, okay? So I do have some practice problems, so if you would like to try them, now's the time to pause your video and I will write in the answers. All right, final answers are up. Again, as always, if you would, we are going to go over these in class, but if there's any in particular that didn't make sense from up above in some of the previous examples, feel free to reach out and email Miss Hardy. Good luck, guys, and you guys can start working on the practice.